Hello class, this is a video tutorial on the application of trigonometric derivation part 1. Using the gradient function, which is also the derivatives of functions, we can calculate the following. We can calculate the gradients of tangents at a point, and then we can also calculate the equations of tangents at a point. Let's do two quick examples here. Let's calculate the equation of the tangents given the function and x value. So we have y equals sine x at pi on 6. So in order to do this, we're going to utilize the gradient point formula. In case you've forgotten, we need y minus y1 equals m bracket x minus x1. So in reality, we need to find the gradient and the point x1, y1. Let's start first. Let's find the point P, x1, y1. So let's give myself a heading. This is how I actually organize my work to make it easy for myself. P, x1, y1. But we have x1. It's here. That's the point we've been given. We need to find the y value at that point. So let's substitute pi on 6 of sine x. Well, pi on 6, in case we've forgotten, is, well, that's pi on 6, that's sine 30. It's going to be 1 on 2. Okay, so sine 30 is opposite over hypotenuse. So sine pi on 6 is actually just half. So the point that we're using is going to be pi on 6 half. We're almost there. Now we need the gradient. So m. We need this to be y prime at the point x. Okay. So let's derive our function y equals sine x. So we have y equals sine x. Y prime will be cosine of x. And if we substitute our given point, pi on 6, we get cosine pi on 6. And in case we've forgotten what this is, we can draw it once again. It's 1, 2, root 3. This would be pi on 6. That's pi on 3. So root 3 on 2. Root 3 on 2. That there is our gradient m. Now, just a matter of substituting it into our gradient point formula. Putting it all together, we get y minus a half equals root 3 on 2 x minus pi on 6. I'm going to get rid of this denominator first by multiplying by 2. So we get 2y minus 1 equals, I'm going to expand this at the same time. This will give me root 3x minus pi root 3 on 6. Okay, I think I'm going to make this into the general form. So this will give me, I'm going to keep root 3 where it is. So it's going to be root 3x minus 2y plus 1 minus pi root 3 on 6. And lastly, just to make, this should be equal to 0. And lastly, I'm just going to multiply by 6 to make it all, with no fractions. So multiplying by 6, we get 6 root 3x minus 12y plus 6 minus pi root 3 is equal to 0. That is our equation of the tangent at the point pi on 6. Let's do my next example. You can follow along, you can pause it and give it a go yourself if you like. But I'm going to finish this question right about now. So once again, we have the x value here, and we need the y value. So let's start with that one. So p x1 y1. So I know what I'm calculating here. So let's substitute pi on 8 into our function here. Function f of x, so it's f of pi on 8 equals tan 2 times pi on 8. Well, this is just tan pi on 4. If you've forgotten our exact ratios, this is pi on 4, 1, 1, root 2. So tan pi on 4 is just tan of this is 1 on 1. That is just 1. So the point that we're using is going to be pi on 8, 1. Let's find my gradient. And for this, we need the first derivative. Here's my function, f of x equals tan 2 of x, and f prime is equal to 2 sec squared of 2x. We're going to substitute now pi on 8 in this function to give us our gradient at the point. So 2 sec squared of 2 pi on 8. This will give me 2 sec squared of pi on 4. Once again, you're going to have to utilize our exact ratios. We draw it one more time. Pi on 4, 1, 1, root 2. Now, sec squared is 1 on cosine. So let's find cosine for this one. So cosine of pi on 4 is equal to 1 on root 2, which means sec of pi on 4 is equal to the reciprocal of this, which is just root 2. So the value we want is root 2 squared. It's going to be 2 times root 2 squared. Well, that is just 4. So we have a gradient and we have the point. Substitute this into our equation. Y minus 1 equals 4 bracket x minus pi on 8. For this one, since I think it's easier if we just use the gradient intercept form, we get, let's expand this one first. We get 4x minus 4 pi on 8. That's y minus 1. Simplifying this right hand side, we get 4x minus pi on 2. And we're going to move this minus 1 by adding plus 1 to both sides. Simplifying the fraction, we get 4x minus, actually let me rearrange this. This is going to be plus 1 minus pi on 2. And this will become 4x plus 2 minus pi on 2. And that is the equation of the line of the tangent to this curve tan 2x at x pi on 8. Okay, so I hope that gave you an insight into using applications of trigonometric derivations. I'll see you in the next video.